Good afternoon, everyone. My name is Madison, and I'm the Regional Engagement Coordinator at NAFA. Welcome to today's webinar on off-road electric equipment as a part of the 2024 Sustainable Fleet Technology Series. Before I turn things over to our speakers today, for the session, there are a few housekeeping notes we need to review real quick. The session is being recorded. We encourage you to ask questions and add comments using the chat and Q&A features. You can find these on the Zoom toolbar at the bottom of your screen. And then if you experience any technical difficulties, please reach out to the NAFA team by emailing events@nafa.org. And to kick things off, it's my pleasure to introduce our moderator, Heather.
Hello, everyone. My name is Heather Brutz. I am the Transportation Program Director for the North Carolina Clean Energy Technology Center. We are a public service center based out of North Carolina State University. And we have been co-hosting the Sustainable Fleet Technology webinar series with NAFA for a number of years now. Really excited to have all of you here today. Today's topic is off-road electric equipment. And so really excited to have everyone here. And going to start off with a little bit of housekeeping. And it looks like there's a little lag in terms of my slides aren't advancing. Give me a second. And let's see. Let's go and start this from the beginning. Okay. And are people seeing the slides or the presenter view?
Presenter.
Okay. And does it look good now?
Yes.
Okay. Okay. So wanted to start off with a thank you to our sponsors. Geotab, eBoost from Pioneer eMobility, the U.S. Soybean Council, and Lecky Services. And our first speaker today is actually from one of our sponsors, Scott Bradley. So just a little preview there. Did want to make sure that everyone knew about the NAFA Institute and Expo in Long Beach this year. It'll be April 28th through 30th. I've been to the NAFA INE in the past. It's a fantastic conference, great networking opportunities. It is a very fleet-focused conference, so you'll really have a lot of opportunities to go to network with other fleet professionals. And Long Beach is a beautiful city if no one's ever been there before. And we at the Clean Tech Center also run a fleet conference that is August 25th through 27th, 2025. And that will be in Winston-Salem, North Carolina at the Bend Convention Center. So we hope to see you there as well. So our panelists today, we'll be starting off with Scott Bradley from Pioneer eMobility. And then we will have Preston Moore from John Deere, James Nielsen from Hyster, and Rose Zoki from the Port of Long Beach. So I'm going to start off with Scott Bradley. He's the Director of Sales and Strategic Partnerships for Pioneer eMobility. He leads the Pioneer eMobility eBoost off-grid infrastructure team, which I think is going to be primarily what he's going to be talking about today. He's an enthusiast and devoted electric vehicle advocate. His areas of expertise encompass EV charging and EV charging infrastructure. He has more than a decade of experience working in and exploring technology and energy industries, and has spoken at a number of national events. He's a researcher and a historian in the evolution of electric vehicles. He got his master's degree in electrical engineering, robotics, and AI from Brown University. So with that, I'm going to go and pass it over to Scott.
Heather, thank you very much. Very excited to be here. Love talking about off-road electric equipment. One important part of that certainly is some way of charging that electric equipment, right? Because we're now looking at very remote locations, locations that might not have access to grid power readily. And so I think there's a very good match between off-road electric equipment and what we call off-grid electric vehicle charging. And here we see it's a Class 8 truck, but it needed charging and pulls up to what we see as a portable and mobile off-grid electric vehicle charging station. Next. So a couple challenges, first of all, that happen, and I always like to start out with challenges to then look at solutions. So the first is simply overcoming delays in EV infrastructure. It's something that a lot of people don't think about, but if you're going to roll out electric vehicles, you do need some way of charging them. On fleet perspectives, oftentimes that can be a year, 2 years, 3 years while they're waiting for permanent infrastructure. So one thing to look at is the opportunity for temporary infrastructure that can be used until there's a grid connection for charging. Another challenge comes around when infrastructure is on leased land, right? And you can't get permanent infrastructure because there's always that challenge of, as a leasee, do I pay for it? Or does a leasee allow me, or the leaser allow me to use it? And then the last part around that infrastructure is simply resiliency, right? So it's not like a gas vehicle where you go and you put more gas in it. If your electric infrastructure goes down, you need a backup solution as well. I mean, all that makes sense in the power world, but now it's just a different way of advancing our vehicles. Next. The other challenge that comes up. Next. The next challenge that comes up is around just very remote locations, and that's what we're looking at the area of off-road infrastructure. Next. And that's where, again, with off-road, the beauty is, of course, whether it is, for instance, construction, or if it's agriculture, these are places that sometimes are very far from high power electric equipment. And in that case, what you need to do is, again, have some kind of an off-grid electric vehicle solution, something that can be basically a self-sustaining part of your actual electric implementation. Next. Right. So what we see that are in rural areas, certainly underserved, but again, the big one, as we're talking about here, is ConAgra, where it's construction, where things are actually being built for the first time, or agriculture, again, where it is a very remote location. Next. So it's important to look at different ways of solving the problem. And, for me, I like to look at things in general here. One is hydrogen. People talk about using hydrogen to create power. Again, hydrogen being a very clean fuel. Challenge, of course, is that hydrogen right now is very expensive. It isn't easy to transport, certainly not readily available. In fact, we are using sometimes propane solutions to create power to then create hydrogen. Once that is solved, once hydrogen is more ubiquitous for creating power, it can create, again, mini power stations, which is great. Again, challenge being is that hydrogen has been the solution of the future for the last 20 years, and it's still kind of, maybe a decade away. Another option is battery. We look at battery, right? Putting a large battery at a construction site, a large battery at an agricultural facility. All great. It's clean, easy to transport, readily available. But the problem is it's really not off-grid, right? Some way you still need to power and charge that battery to be able to get power for the electric vehicles. So another option is propane. Propane is a clean fuel, inexpensive, readily transportable, and it is readily available around the world. There's really no location you can go to anywhere in this country and not be able to readily get access to propane. So we're going to look here today talking about propane solutions and also next, the mix between propane solutions and batteries. So having batteries on site, but then being able to recharge them using a propane powered solution. And then that enables truly off-road electric vehicle solutions. Next. So again, why propane? Why are we going to talk about propane here? How clean is it? And if we look at the number of different fuels out there, in fact, if we look at the grid itself, the U.S. grid is a fifth coal, a fifth nuclear, two-fifths natural gas, and only a fifth renewable. Now you get to cleaner grids like the California grid on a normal day meaning partly cloudy, mid amount of wind, right? So we're not talking the sunniest day, we're not talking the windiest day, but a standard day. We see that propane is actually cleaner than that, and actually propane is cleaner than the grid in 38 states. So a very clean fuel. In fact, it's clean enough that we barbecue on it, right? You never heard about a diesel burger, but propane we cook on every day. Next. But to get even cleaner, again, what we're looking at is marching to net zero. And again, I use California because it looks as a cleaner grid. On very windy days, very sunny days, its grid actually goes down in carbon intensity significantly. But there's now something called renewable propane available, started out in Texas, California, up the West Coast, and then Louisiana, up the East Coast. It's made from bio-waste and biomatter. It's still propane, same molecular structure, but it's from renewable resources. So think about, for instance, soy, where 80% of the soy bean is used for food. There's a 20% waste in husks that can then be condensed, modified, and then create renewable propane from that. So again, ways to march to net zero. And in fact, there's an additive now, RDME, renewable dimethyl ether, which has a net negative carbon intensity. And that actually enables with a mix of 20% by weight, 15% by volume, to bring renewable propane to net zero as well. Next. So here we're going to see a little animation. What we always talk about is not cliff diving to decarbonize, right? So if you're waiting for the grid to be brought to your location, you could be waiting 1, 2, 3 more years for full power. And instead of waiting for that amount of time using your diesel vehicles, instead it's best to start sooner, right? You can use off-grid electric vehicle charging today to start down that curve, right? Advancing EV adoption, really leveraging the green movement today to eventually get to connect up to the grid and again, eventually get to that net zero possibility. Next. So of course, people always want to know about operational expenses, comparing propane as a solution, an off-grid solution versus the grid. And looking at California as an example here, the California grid is going to be a little bit less than propane operationally when you're using it at the time that you're told to use it by the utility. But if you're doing it during peak times, that cost goes up significantly and it becomes more expensive than just leveraging propane. And once you hit peak demand charges, and that continues on for your next month, suddenly you see that the grid becomes quite expensive if you don't do your charging at the times where they really want you to. So again, from a sustainability perspective and an operational perspective, suddenly we see that off-grid charging is not only ubiquitous, right? You can move it around anywhere you need it for off-road, anywhere your off-road is, but also economically as well. Next. So what I want to do is we talked about this off-grid charging. We saw a unit earlier on. I want to bring it back to that unit and look at what's involved inside a unit. So next, what we'll do is we're going to open it up and look inside it. So what's inside a typical off-grid charging solution? And again, in this case, I am going to show you something specific, but we'll think broadly. Next. So inside these units are going to be either DC fast chargers, right? If you want to do very quick charging, you're doing farming equipment and you're coming in, you want to be able to very rapidly recharge that tractor. Or it could be level 2 chargers. So if you have a small fleet of your delivery vehicles, and those are charging overnight, right? Those can leverage level 2 charging, charge more slowly. So off-grid charging can be either DC fast charging, very fast, could go up to 240 kilowatts of charging, or it could be many, many level 2 chargers, or it could be both. So in this case, it happens to be a mix of a DC fast charger, multiple level 2 chargers, and then some kind of a propane generator. And that propane generator could run off of propane or renewable propane. And then some amount of onboard propane storage as well. And again, that's if you're going to move it, because you could be at a construction site and you want to move it from one location to another on a regular basis. In a farm as well, you might want to move the charger to the tractor instead of the tractor to the charger. Next. Now, with that also is the importance of, because it's off-grid, being able to monitor what's happening. All right, you may have one unit, you may have dozens of units charging over large environments. So be able to monitor in real time what's happening with the charger. Is it up, down? How many kilowatts we're actually charging? Monitor the generator to look at its up, down status, its health, and then monitoring the propane to make sure that if it goes low, we can refill it very easily. And then, of course, all sorts of other pieces in terms of having solar power, etc. Next. So regardless of what one is doing, whether one is leveraging eBoost, our organization for charging, or some other type of off-grid charging, they come in many different shapes and sizes and flavors. Anything from a skid that you could put down is just it's gonna sit there and you'll bring your vehicle to it. Something that's mobile, like in a trailer where you can bring that power to it. Or if, again, once a construction site is finished, you move it to another one. A pod where it's more semi-permanent, or a truck where it comes and if something needs a boost midway, you can recharge it. So, charging power could be anything from 30 kilowatts to a megawatt of power for chargers, depending on what the equipment is. Off-grid power can do anything small from 700 kilowatt hours of power to 75 megawatt hours of power, which would be, for most sites, that would be a year of power, all off-grid. And again, whether it's leveraging DC fast charging or level 2 chargers. Next. So, why am I talking about this? Well, in the past, we've charged over 12,000 vehicles, electric vehicles, produced over 400 megawatt hours of off-grid energy. Now we are seeing an exponential rise in this demand for off-grid energy. And in fact, this year we'll produce over 10 gigawatt hours of off-grid energy. So we're seeing the electrification of off-road electric vehicles and other vehicles moving very rapidly. Next. So I want to wrap up with just a few examples. One very remote, right? Again, we talk about off-road. Now I'm talking about a highway, but this is northern British Columbia, just south of the Yukon border. And it's an example where they need to charge electric vehicles in a location you would not expect them to be. And we actually put in 4 stations across the Alaska Highway. When we put them in, I was thinking, when is the first person really going to come and use it? Will it be next year, the year after? We hadn't finished commissioning the first unit when the first electric vehicle came driving down, very excited to see that there was some kind of a solution for charging truly, truly remote. Next. Now, as sites get bigger, and in interest time, next, looking at e-transit, and again, it's what I'm looking at is just number of places trying to solve a problem. In this case, it was an organization where it was going to be 3 years till they had permanent infrastructure. All right, so whether it's remote or just off grid, and they'll be charging about 7 megawatt hours per night in terms of power. This is 48 e-transit buses. But that could easily be a construction site with large equipment. It could be a very large farm with a lot of equipment. Next. And just because bigger is better, next. From an electric school bus perspective, there's a fleet of 200 electric school buses. Again, with the challenge of not being able to charge and get permanent power, right? So again, it didn't matter if they were very remote, or in this case, although they're in a city, they need a lot of power in a short period of time. And they'll be doing about 5 gigawatt hours of energy off grid every year just to charge this equipment. And what we see in here, in between those buses are off-grid charging systems where each one is charging 8 vehicles at a time. So if you're doing off-road construction equipment or farming equipment, it's able to bring it over, connect it up, and charge very quickly. Next. So as I wrap up, I put a little LinkedIn connection if you want to link in as a connection. And here again, we see just another live example of off-grid charging. It doesn't matter if you're charging one vehicle or a dozen, but as you go, the more off-road you go, the more important it is to have some kind of an off-grid EV charging solution. Heather, thank you very much.
Thank you, Scott. So our next speaker will be Preston Moore with John Deere. He's the long-range product planner for batteries and charging solutions for John Deere. He has worked there for more than 16 years, and he works with more than 20 electrification teams around the John Deere enterprise. His specialty is working on the batteries and determining which batteries they should produce and use. And so he's worked on more than 60 vehicle programs during his time with John Deere. And so I'm going to turn it over to Preston Moore. Thank you.
Yeah, thanks, Heather. Before we advance the first slide here, Scott, great job summarizing the off-road space. Many of the same themes that Scott touched on, I see the same way. You have very restrictive items that need to be paid attention to in the off-road space. And so coming from completely disconnected off-grid, I'm going to step one layer in and go to the edges of the grid here as we talk about these next few slides. So let's go ahead and go to the first slide here. To level set on a couple of terms and make sure that we're all talking the same language, when it comes to charging stations that are providing EVSE charge to electric vehicles, we've got level 1, level 2, and level 3 charging. If you think of level 1, that's like your 110 volt outlet in your house, something simple that you'd plug just about anything into. Level 2 gets to that 240 volt. It's still a single phase connection. It gets up to an 80 amp circuit that can provide about 19 kilowatts of charge power to a vehicle. And that would be kind of the mid-level if you're thinking of a site that has a little bit of fuel storage. It's kind of analogous, right? It's something that can get you by for a small amount of time, but it's not something that's going to be what you would run a full operation off of. And then you get to level 3, where you're really dependent on 3-phase grid connection. You're anywhere from that 30 to 480 kilowatts. If you start to get over 480 kilowatts, then you get into liquid cooled cabling. You get onwards up to the megawatt charging that some fleets are going to be in need of. But for most vehicles, a level 3 below that 480 kilowatt level is going to be pretty appropriate for a lot of daily use for some of these vehicles. As you move out on the fringes of the grid, it gets more and more important to pay attention to what can the grid provide and what can you do. Just as Scott was alluding to, sometimes the grid upgrade timelines and cost investment is very high and very long. We're seeing lead times of anywhere between 20 and 40 months. And as you continue to do those upgrades, it gets pretty costly pretty quick, because the grids don't upgrade proactively. It's as the need arises. And so then a lot of times when you're requesting these, then you're looking at the transformer cost and the line upgrade costs. So that's the area that that we're looking at to solve for our customers as well. The next slide, what we're looking at in terms of how do you start to walk a customer that has an existing operation into selecting the right vehicle, selecting the right charging hardware, and understanding how do they work with their electrical contractor, how do they work with their utility to appropriately get set up. And there's some nuances here that I want to make the group aware of, because it's not quite just as simple as pick your vehicle and then pick your charging station. It to be the most cost effective for the operation, it really needs to be looked at all at the same time, all in tandem. So let's take just a simple case study here, that if I'm looking at a vehicle, and some of the vehicles I can either choose to purchase at a lower price point with certain battery chemistries that are maybe more lithium ion based or lithium iron based battery chemistries, or I can go more towards the higher end of the spectrum that has nickel, manganese, cadmium chemistries that are more energy dense, which what that means is I can put more energy on the vehicle. I can run that vehicle for longer during the day and not have to have as many opportunity charges sessions during the day. But the decision point on that vehicle then makes a difference on, should I have if I need fast charging capability, do I select a 100 kilowatt charger, or do I select something larger, like a 200 kilowatt charger? And if I'm making that selection, then working backwards from the charging station, well, I might have 3-phase power coming to my site, but at what power level? If that 3-phase is only a 60 or 100 kilowatt connection, and I want to put a 200 or multiple 200 kilowatt chargers on the site, well, now all of those decision points back up into the grid connection, such that I have to get the utility company involved. Do I have the right transformers? Do I have the right hardware in the grid infrastructure piece of it? And so this is the example of where walking the customer through that journey, helping them make the decisions, making sure that the vehicles and the portfolio of charging stations is available and appropriate, and that the services are there that dealers can help customers is really a critical piece of the equation. And when Scott is referring to the heartache and the time that it takes to get some of these in place, this is exactly what he's talking about, and we see the same pain point for our customers. The next slide, we start to see some of the decision points. A lot of it comes down to how much work do you have to do on a daily basis, how much energy can you put on the vehicle, and how much dwell time or how much non-working time do you have to charge it. Those 3 pieces of information start to roll up to help you make a decision on, can I get by with a single phase level 2 charger, or does my operation necessitate that I use a level 3 charger and have fast charging capabilities? So as the example here, if the backhoes or tractors that we are working on have enough energy to get through a full day of runtime with an 8-hour shift, and then have the overnight 16-hour period, in that type of example, I probably could get by with a level 2 charge, 20 kilowatts per hour, can charge back, the 100 or 200 kilowatt hours of energy on the vehicle that I need to do that with. Conversely, if I'm using that vehicle at a higher duty cycle, doing a lot of heavy work with that vehicle, if I'm depleting it before a full day of runtime, now I need to have an opportunity charge during the day, maybe over lunch breaks, etc., so that I can get enough energy to complete the day, the working time, and get by. So to put a crisp point on understanding energy output, energy on board on the vehicle, and the dwell time that I have to recharge the vehicle are critical decision points and pieces of data that I have to understand for the customer. Next slide. Once I know, okay, I want to have a backhoe. Let's say that I have 100 or 200 kilowatt hours on that vehicle. Now I know that first yellow bullet point, vehicle battery, and the size of my battery. As I'm talking about understanding how much dwell time overnight. Okay, now I can make a decision on, do I need level 2 or level 3? I can start to step the customer through this decision-making process. What kind of charger capacity do we need to scope for that? What kind of price is involved for the hardware? What kind of price is involved for the grid upgrade? What is the infrastructure status? Do they have single phase or 3-phase service to the site that they want to run at? The runtime estimation and needed runtime is important to understand. That gets us down into being able to have a connected device where we can see and monitor and advise the operator how that works out. And then other considerations gets into, do I have an excursion event of work that needs to be done where I need to leverage a mobile device to help extend the working time of that vehicle out in the field? How far away is the work from my charger? Because I don't want to expend a lot of needless energy to move the vehicle back and forth to the charging station if I don't have to. Those are other considerations that have to be taken into account. So you can see the charger portfolio example that I've got listed up there, whether that's the level 2 on the pedestal or a roll around unit, or the level 3, or a mobile similar to the mobile that we just talked about, except not with a natural gas generator on board. It's just batteries to transport energy. But a unique piece that we have identified for edge grid scenarios is a level 3 charger with battery backed integration. So that charger with the green arrow coming from it has a battery integrated inside of that charger. And what that enables us to do is be able to deliver high power, fast charging off of a lower grid connection. So it's a little bit hard to see, but in that graphic, you can see that the charge delivered in the green is being provided by the battery. So in this example, 120 kilowatt grid connection plus the battery usage as the vehicle is charging, we can provide 240 kilowatts of charge power to enable that fast charge without having to upgrade the grid to a 240 kilowatt grid connection and transformer service. That can save a tremendous amount when we're talking hundreds of thousands, if not $1 million of infrastructure upgrade to be able to provide the same type of fast charge from that type of equipment. So that's one unique facet inside of the portfolio that we're including into our planning. And then into the battery aspect is leveraging the high voltage batteries with high energy density on board to get as much energy on the vehicles as possible. So in the next slide, now same graphics, but I'm going to break the left part of the slide up into two columns here, battery and BEV aspects of how our approach is forming up, and then the charging aspect in the second column. So when we're talking about the battery and the BEV itself, the parts that we're focused on is we have to have outstanding safety. We cannot afford to negatively impact these sites with batteries that aren't meeting our safety criteria. That's first and foremost. But then, as I'm referring to, keeping a focus on energy dense batteries. When we're maximizing the amount of energy we can get on the vehicle, we can then decrease some of the burden that comes along with the infrastructure side of the equation. The active thermal management helps us use that battery to its max performance. The blue graphic in the middle bottom is a graphic of the immersion cooling that we use on the batteries. And what that does is when we can fully control the thermal attributes of the battery, we can maximize its life, we can maximize its performance during the day, and we can really well control those charging events as well when we can control the thermal management of the battery and getting into the integrated solutions. So on the charging side, have the right solution fit to the right job. If we're needlessly throwing the wrong charger at the wrong job site, that's going to cost the customer valuable dollars that they could be using in other places in their business. The edge grid solutions, while still maintaining fast charging, whether that's the battery-backed charging station that I referred to, or whether it's a battery mobile charger that can deliver and move energy and still deliver a fast charge. Those are aspects of that plan. And maintaining visibility and keeping the infrastructure impact low to the customer, as well as the connected intelligence. So those are the attributes that we are trying to address for our customers, from the hardware, from the charging solution portfolio aspect, and bringing those solutions to our customers and to the job site. The next slide, really the other piece that that executes this is the dealer network and training our dealers in BEV. I think the dealers and the market in general is well accustomed to heavy machinery in the diesel world, but getting that same network educated and up to speed with electric vehicles is a critical part, and enabling them to walk the customers through this charging infrastructure conversation is really key to help them get their operations up and running. Finally, I'll end with the battery and the battery-backed charging station on the next slide is coming from Kreisel Electric. So John Deere has taken a majority stakehold in Kreisel Electric for vertically integrating our batteries with our vehicles and the battery-backed charging station. They're in approximately 11 countries in Europe with the battery-backed charging station in use, and getting some great results inside of that. But if you've got any questions or thoughts around those, I'd refer you to the KreiselElectric.com website. And I would love to entertain other conversations and questions, whether it's in this forum or whether you reach out to me directly by my email. Either of those options work. So thank you for having me, and thank you for the time.
Thank you. And I'm going to stop sharing briefly. So our next speaker will be James Nielsen from Hyster. James Nielsen is the Senior Business Product Manager for Motive, Power, and Electrification. He's worked at Hyster for over 14 years in different roles, from engineering to product management. He works to bridge the gap between engineering, dealers, and customers to drive electrification and sustainability of the material handling industry. So I will now turn it over to James Nielsen.
Hello, thank you, Heather. Thank you, everyone that's here today and the presenters already. So I'm here to talk about material handling equipment specifically, and hopefully you can see my slides here. So I just want a quick level set on material handling, since material handling covers so many different pieces of equipment and topics, all the way down from a single pallet jack all the way to a giant reach stacker at a port. So I wanted to kind of narrow it down, the focus today, and I'm really just going to talk about specifically the trucks that we got here on the screen, a sit down counterbalance truck that you kind of think of in your head as a forklift, ranging from 3,000 pounds up to about 19,000 pounds is kind of what I'm talking about today. So what we have is our electric class one, and then we have internal combustion class four, which is what you drive inside, and class five, which is basically the same kind of truck, but you drive outside with big pneumatic tires. So that's just kind of a level set of what we're talking about here today. So I want to start with kind of what's the market doing just in general to kind of give you a sense of what, other fleets around the nation are doing. And this is North American data only here. So this is US and Canada. And you can go all the way back to 1984. And back in 1984, we were about 80% electric, sorry, 80% internal combustion as an industry. And if we kind of fast forward all the way to about 2017, and back in 2017, we were about 73% internal combustion. So over, 33 years, we only shifted 7% towards electric. But what we're seeing here, really a kind of a drastic swap. And just in a handful of years to 2023, so just 6 years, it shifted 10%. So 33 years, we shifted six, and just the last six, we've already shifted 10%. And I just looked at the numbers this morning and for 2024, and we're kind of on pace. We're about 50-50 chance of getting below 60% internal combustion in terms of sales in this type of forklift. And there's quite a few reasons for this. And I want to start on the market side, right? There's the higher cost of fuels. There's higher cost of maintenance, cost, parts, and labor, which is kind of pushing the ROIs more and more towards electric when you're looking at fleet maintenance. But there's also the sustainability side of it as well. The emission regulations. We have places like California that are going to start pushing people over to electric. And then we also have corporate initiatives. We see more and more corporate initiatives to move electric for sustainability reasons. And I want to kind of quickly just give an idea behind the sustainability of this type of equipment. You only have, so many dollars per year to work in your business, and when you're making choices on what to electrify first, do I my vans, my forklift, et cetera, kind of give you an idea of where material handling fits in. So for reference here, I've got kind of just the average automotive electrification. So average US car is about 4,300 pounds, drives about 11,000 miles per year, 22.2 miles per gallon. So its emissions is about 4.6 metric tons per year for the average light duty vehicle. When we go to material handling, the truck itself, so a 5,000 pound forklift is kind of your generic median forklift. The truck itself is 9,000 plus pounds, so it's almost over double the automotive car. And then it picks up that car plus some and drives it around all day. So we drive on kind of on average about 1,500 hours per year is your kind of prototypical forklift, 1.28 gallons per hour or per hour, and then you get about 10.7 tons of emissions roughly per year. So we're looking at almost 2.3 times as much emissions for one forklift versus the average car. So when you're thinking about where to put your dollars, that kind of gives you some concepts of your emission savings. But there's also the flip side, there's a lot of conversations around the sustainability of making batteries and the opportunity cost there as well. So if you look at the average car that emits 4.6 tons on average, kind of your Model Ys, your VW ID4s, etc., they're about 60 to 80 kilowatt hours of battery. So it takes about 13 to 17 kilowatt hours of battery to eliminate 1 metric ton of CO2 per year. When you go over to material handling, we actually do in about half the battery size. Since we're always so close to the charger, we don't need as big of a battery. You don't have the range anxiety automotive has. So we only takes about 3 to 4 kilowatt hours to replace a metric ton of CO2 per year. So the costs, opportunity costs, and the actual overall emissions, it's actually the material handling kind of outkicks its coverage when you go to the electrification side of things. So moving on beyond, the market side, there's a bunch of technology changes that have happened. Hyster's been building trucks for over 100 years, and I get repeatedly told that this change to electric is technology-wise and market-wise is one of the fastest we've ever seen as an industry. So I'm going to kind of touch upon a few different things that have changed in the last, 3 to 5 years. So if you haven't looked at electric trucks or making the shift in the last, since COVID, I kind of want to highlight what's changed since you may have last looked. So the first side is batteries. So batteries has kind of traditionally always been the limitation to move electric. If you were looking at electric forklifts prior to 2018, you only really had one option, which was lead acid. We've been using lead acid as an industry for essentially 100 years on our electric trucks, and they've been really good for what they do, but there's a lot of drawbacks. There's emissions when you're charging. You have to have there's potential for acid spills. You have to maintain them. Their life is relatively short. So if you're looking at 2018, that's kind of about all you could choose. But what changed in 2018, which coincidentally lines up with where the shift in market electrifying kind of happened, is when well you saw lithium ion come in. So lithium ion, of course, is fully sealed. There's no off gassing. There's no watering. It charges much faster. It has a much longer life. Um, but back in 2018, if you were looking at buying a lithium battery, they were very, very expensive relative to lead acid, and they were not integrated into the forklift. We basically took the lead acid out, slid a lithium in, and the trucks didn't really know what to do with that. So you have secondary displays hanging off of them. They weren't really integrated. They didn't really work well together. So what's what we've seen met that market mature over the last few years. So if you look from 2018 to 2023, that motive power market has really matured. We've got a new lead acid that's came in called thin plate pure lead. It's kind of like a stepping stone in between your traditional lead acid and lithium. It's got all those benefits of being fully sealed, no off-gassing, no maintenance. It charges faster than lead acid flooded, but not as fast as lithium. It has a longer life than flooded, but again, not as long as lithium. So it's kind of that middle point. But we're also seeing lithium prices start to kind of drop relative to lead acid. And the lithium products are becoming more integrated into the equipment. They now talk to the truck. They can the displays on the trucks actually show what's the battery's doing. It can throw battery fault codes, so they become much more integrated and part of the truck itself. And where we see the market going in 2024 and kind of continuing on is lithium maturing even further. We're starting to see introductions of even lower cost lithium, and lithium itself is starting to segment out into different types of lithium, different price points, different charging rates, and so on. So lithium is really starting to spread further and further away from that niche high end to a full suite option. And we're starting to see forklift models themselves actually change to accommodate only lithium ion and kind of dropping lead acid away. So if you kind of look at what that means on the truck side, on the truck technology, we're starting to see designs again, as I said, only around lithium. So the truck on the furthest left there is what was traditionally a lead acid truck, now kind of redesigned to run a lithium only. So you can't put a lithium in there, and you start to open it up. One of the biggest complaints on electrics previously was ergonomics, trying to sit on that big battery. When that goes away, we can start to change and fine tune things. On the bigger side of trucks, you start to see, as an industry, your big internal combustion trucks, where they actually have taken out all the internal combustion bits and putting in high voltage lithium ion. Previously, back with lead acid only, we were kind of capped at 80 volts, and their performance really suffered on those big trucks. Now with lithium coming online, we get that high voltage performance, and now these trucks actually are one-to-one. You couldn't tell the difference if you walked outside, walked at them. If you saw them performing in the yard, the only way you could tell the difference between the electric and internal combustion is there was no exhaust and there's no noise. So in terms of performance, they're starting to become really close to one-to-one with your old internal combustion trucks. The other thing as an industry we see more and more is the shifting away from the one size fits all. Previously, again, 2020 and earlier, if you're looking at a 5,000 pound electric truck, you had one option for per supplier, kind of this. This is what you have. This is it. So if your application fit that niche, you were good to go. If you kind of fell outside of that, you kind of didn't have an option. But now with the, again, technology improving, cost of components dropping, we're starting to see more and more models that spread the width of the entire market. You're starting to see low cost electric trucks, some higher performing electric trucks. So now there's more options just across the board on picking your units for your application. So if you look before and there was an electric truck that could meet your needs, now there's likely a truck that can do that. There's also been a huge increase in technology. Now, when we move over to the electric trucks, there's a lot more controllability, a lot more logic behind it we can enter that we couldn't on internal combustion. So you're seeing a lot of a rise in operator safety systems, LiDAR, object detection, proximity detections, all those type of equipment where we never as an industry had them on internal combustion, we can now start to add them to the electrics. And then charging. So as previously in 2018 and earlier, kind of your limitation to go electric was always your battery. If the lead acid didn't do the job, then you couldn't do it. As lithium came in, the limitation became more of the truck. And now, over the last few years, with all those different models and increases in technology there, the truck is becoming less and less of the limit. And now the limit, if there is one on electrification, is charging. So that is really the issue in the future is how do we challenge charging overall? There has been an increase in a lot of flexibility in charging. As they talked earlier about the level 1 charging, level 2 charging, that's being implemented more and more in material handling. But we run into the same things if you have a large fleet, the bigger trucks, charging becomes the limiting factor as you look into the electrification. So that was a lot. So I just want to jump in real quick with a case study here to kind of wrap things up and how we go from the internal combustion to electric. So this is a site that I helped on, and that's really what I do a lot is helping our dealers and our customers make that journey from internal combustion over to electric. So this is an example I worked on. It's a facility in Utah. They had 35 trucks. They had tried to go to electric previously around 2018 with lead acid, and it did not work. It failed pretty spectacularly. So they were trying again with their corporates. They really wanted to go electric. So we came in with the newer technology to walk through it. And this is also the area now that the industry as a whole is working through is how do we go from what was like a 1 day sale. We go in, look at your application. Here's the internal combustion truck that works. You're good to go. Now we have to go through the electrification process. As I mentioned, we have all these different models, which is great, but it also becomes a catch-22 is how do I help you figure out what truck you actually need? We have multiple battery types. How do we figure out what type of battery that you need? Those batteries come in different sizes. How do we know what size of battery? And then also the chargers. How do we know what size of charger you need? So that's a journey that takes weeks, if not months, to walk through that process. So there is that level of expectation that it's going to take a longer process. It is a journey and a process to get through that step from internal combustion over to electric. But it can be done, and there are steps and processes to do that. And then once we figure out all the truck that will work for you, the battery, we can also spot check now the ROIs, the return, make sure it makes financial sense even. In this application, you can see the fuel cost per year. This is per truck. Went from $15,000 to just under 2,000. The service costs go from $10,000 down to like 6,000. And you can see the ROI for total cost of operation and acquisition plus usage. The cross even point is just under 3 years for this application. And they run their trucks over 5 years. So they're going to have significant savings towards the end. So we go through that process. You go all the way from internal combustion to the electric. So the update now, they had 35 trucks, but when they actually went through and actually purchased trucks, they only did a portion at a time. So that's the other thing. You don't have to do the full gamut. You don't have to take the giant conversion. You don't have to do everything at once. Many applications we go through and fleets, they do it piecemeal at times as they go through. So they did 20 in year one. And then once they were comfortable with that and everything was fine, then they moved on to the remaining 15, which were kind of the higher priority trucks that if there was an issue, it wouldn't cause major issues to the line. So they kind of worked through their priority of trucks. At this point now, all 35 are converted. the average electric truck runs 3,700 hours per year. They have trucks running up to 5,000 hours per year. Trucks that were installed in February 2022, they have over 11,000 hours of actual service time running, and they've reduced their CO2 by 728 tons since they moved over, which is equivalent to removing 1.8 million miles of automotive. So you can see just one site in Utah can have a pretty big impact in terms of your sustainability and electrification. So with that, I think I hit 15 minutes. Here's my contact, but these will be out afterwards as well. So thank you.
Thank you. Let's see if you can, I will go and start sharing again. And okay. So our next speaker is Rose Zoki, who is the Senior Environmental Specialist for the Port of Long Beach. So Rose leads the Technology Advancement Program at the Port of Long Beach. That's an initiative to facilitate the development and demonstration of clean technologies in partnership with the Port of Los Angeles under the San Pedro Bay Ports Clean Air Action Plan, which I think we're going to be hearing more about. And so this funds real-world demonstrations of emerging technologies for port-specific mobile sources. And so Rose is going to be talking to us about some of examples of that today. In addition, she has successfully overseen the administration of over $22 million in state and federal grant-funded projects to the port. And these were funds that were aimed at reducing emissions from port equipment. And so her current roles also include managing the development and feasibility assessments for zero emission drayage trucks and cargo handling equipment, and overseeing the development of incentive programs designed to further the deployment of zero emission cargo handling equipment. She holds a Bachelor of Science in Applied Ecology from the University of California, Irvine, and a Master of Science degree in Environmental and Health Sciences with a concentration in industrial hygiene from the University of California, Los Angeles. So thank you, Rose.
Thanks, Heather, for the introduction. So again, my name is Rose Zoki. I'm a Senior Environmental Specialist with the Port of Long Beach Environmental Planning Division. And so you've heard from Scott, Preston, and James, who talked about equipment that's considered commercialized. And so what I'm going to be covering today is cargo handling equipment that's not yet commercialized, just because there isn't a solution yet for terminal operations, which tend to have really high duty cycles. And so a lot of what we focus on is just testing these new technologies out. And so that's what I'm going to be covering today, is just where we are with that and how we go about to doing these demonstrations. Next slide. So quick overview for what I'll be covering today in the presentation is that I'll be talking a little bit about our Technology Advancement Program, or TAP, as we'd like to call it. I'll also be talking about our current technology demonstrations and deployments, as well as insights and challenges that we've gained from these technology demonstrations. And then also a looking forward slide. Next slide. So the goal of the San Pedro Bay Ports Technology Advancement Program is to provide funding support for technology that is not yet commercialized, and that's specific for port operations. So we have 5 sources of categories where we hope to either eliminate or reduce emissions, and that includes ships, trucks, cargo handling equipment, hovercraft, as well as locomotives. But for today's presentation, I'll be focusing specifically on the cargo handling equipment. So we have a website that is dedicated for those who are interested in demonstrating and doing a demonstration project with us, and it's through our Clean Air Action Plan website. We also have an advisory committee that consists of the 2 ports, as well as representatives from EPA Region 9, California Air Resources Board, South Coast AQMD, and the California Energy Commission. So This is a program that is in partnerships with outside agencies and very informative for the ports because we also get to hear from them as well as some of the initiatives and projects that they are currently working on as well as it relates to zero emissions. Next slide. We have a dedicated TAP annual report that's available on our website if you'd like more information on the types of projects that we have funded, as well as updates on demonstration, as well as some of the lessons learned. We have the 2023 TAP annual report available on our website, and we're currently working on the 2024 annual report. So that is expected to be released sometime by the second quarter of next year. Next slide. So I thought I'd go in to some of the demonstrations that we are currently funding. And again, a lot of these equipments, the technologies for these types of equipment are still considered pre-commercial. And you know, we're still learning a lot. It's being put to the test. A lot of times it doesn't work, and a lot of times it does. But for this specific demonstration, we are partnering with one of our terminal operators located at SSA at Pier C, and they are working with Taylor Machine Works, who is the manufacturer of this top handler that you see pictured here, to develop a zero emission option, but using hydrogen fuel cells. And so this is really exciting. It's a technology that the ports we don't have a lot of terminal experience with as it relates to some of these equipment at our port. And so we're hoping to get some more information when we have these units delivered sometime late next year. And as I'd mentioned before, the Technology Advancement Program provides funding opportunities, to help support the commercialization of these types of technologies. And so for each of the slides that I'll be presenting, there's some information in there and how much was contributed from the ports, as well as how much were contributed from the actual demonstration people that we're partnering with. And as you can see, it's a lot of money. It's not a low cost at all for these types of projects. You have this technology that's not yet been commercialized that is built for these larger pieces of equipment. In this case, it's a newly built equipment. And so, we need as much help as we can as it relates to funding these types of technologies. So you'll see high price tags for these types of demonstrations. Next slide. This is a project that we received funding from the California Air Resources Board. And the project involves deployment of 33 electric yard tractors and its associated charging infrastructure at one of our terminals located at Pier C, as well as demonstrating 5 drayage trucks. And both demonstrations have had numerous challenges. They're working to complete their demonstration periods required by the grant. Both the yard tractors and the drayage trucks have had numerous issues with both the vehicle as well as the infrastructure and have continued to be addressed by the respective manufacturers. An additional challenge at Pier C has been getting dealing with the bankruptcy of one of the charging station manufacturers. So again, some of these things were totally unforeseen at the start of these demonstrations. You don't expect one of the manufacturers to go bankrupt, but in this case it did. So that presented a challenge for this particular demonstration. An additional, so this had halted support in getting the charging stations online, but all partners are working diligently to try to get the equipment into working order. This is a grant that we received again from CARB, and it's a $23 million grant. So again, big price tag. Next slide. This slide also highlights another grant that we had received from the 2022 Port Infrastructure and Development Program. And this involves deploying 60 ZE yard tractors and charging infrastructure I don't have much of an update on this just because it's one of the newer grants that we have received. And obviously, with contracting, making sure that we have the schedules in line, that takes a long time. So that's one of the things that we had spent a lot of time working on. But where we are right now is that we are going through the design and the permitting process right now. Next slide. This slide also highlights another grant that we have received from the Port Freight and Infrastructure Program, and this is through the California State Transportation Agency. So this is a project that involves replacement of 63 diesel cargo handling units with zero emission alternatives, including hydrogen powered units, as well as installation of the necessary supporting infrastructure. And this is going to two of our terminal operators, Long Beach Container Terminal, as well as SSA. It also allocates $107 million for the development and implementation of incentive programs that is dedicated to deploy additional zero emission cargo handling equipment, as well as zero emission locomotives and emissions reducing harbor craft. And then it also involves expanding shore power capability over at our Tesoro berth. Next slide. This is a demonstration that is funded through the Ports Technology Advancement Program, and it involves converting a conventional diesel top handler to run on zero emissions hydrogen fuel. This demonstration is located at Phoenix Marine, which is located at Port of Los Angeles. So we've been working with them on their demonstration for about a couple of years now. Some of the lessons learned that we have gained from this particular project was the need to increase the hydrogen fuel tanks in order to be able to get through the rigorous duty cycle, as well as trying to get it through the needed shifts without having to do opportunity charging. Next slide. And next slide. This is a demonstration that was funded through the California Energy Commission. It has since been completed, but it's one of the projects that I'd like to highlight. It involves the demonstration of 8 electric yard tractors manufactured by BYD. These units were deployed at 2 of our terminals. We also had supporting infrastructure to charge these units, 2 of which were modified to take on charge from a smart plug system. And this was through Cavitec. And so we went through this demonstration, and there were a lot of lessons learned from this project. One of the concerns that we had was the fact that this was one of the earlier models of equipment. And there were a lot of technical difficulties. Sometimes the chargers wasn't able to sustain some of the charging infrastructure wasn't working correctly. Some of the units weren't able to take a charge. This was specific for the ones that were involved with the smart system plug charging. There were just a lot of factors, and there was just a need for some of these units to have modifications that the terminal required in order to be able to use them. They had to outfit them with navigation systems. And so that was presented a challenge because we needed to find space for where they would be able to install that kind of system that they need for their work. And so at the end of the demonstration, some of the operators they didn't feel really confident by them. There were some ergonomic issues. Some of these chargers weren't able to last the full shifts required by the terminal. And even though there was opportunity charging, that we hoped that opportunity charging would be utilized in the grand scheme of things when you're working at a busy terminal, they just want to move containers, and sometimes there isn't an opportunity to charge. And so one of the lessons learned from this demonstration was to be able to build a unit that would be able to take them through two 8-hour shifts before it would need to charge. And since then, some of these manufacturers, have been trying to build units where they can meet those duty cycles. Next slide. This just takes you through the commissioning process that we went through, but we don't have to go into great detail on this slide. But it's a nice picture there to just show you, them as they're building these trucks and what it looks like. Next slide. This is a picture of the infrastructure that was installed at the terminal. Next slide. And then this is a picture of the smart plug system. So how it works is that the yard tractor would park, and then there would be sensors to, let the charger know that there was a yard tractor there ready to be plugged in, and then a mechanized arm would come out and make connection to the unit itself. It didn't really work. It probably worked a couple of times. And there was just a lot of software updates that needed to happen on the infrastructure side. And again, when you're working at a busy terminal, operators don't want to have to mess around with this, so they ended up just not using the equipment. At the end of the demonstrations, the terminals opted not to keep these units. They had the first right of refusal. So they didn't end up keeping these units, and they were all returned to the manufacturer with important information on, how they can better develop these units for the future. Next slide. This one just talks about our grid-tied electric RTG cranes. Next slide. So this was a project that involved the conversion of existing rubber-tired gantry cranes into one that operates on grid-connected electricity. Next slide. This is a picture that just shows you the whole conversion process. A lot of this work was done in-house by people that actually worked at the terminals. So this is really interesting to see the step-by-step process. Next slide. And so they also designed a cable reel and guidance system to ensure that the RTG crane stayed along stayed within the intended path and not veer too much to the right or too much to the left, where there was a chance that it could run into the containers. So this was a safety system that was set for this particular equipment. Next slide. And this is just a picture of the ERTG cranes and just some information on the level of effort that went into the conversion process. So it took almost 2 years just to get through this process. It's not an easy task. And to this day, these cranes continue to be in use. And this is, so these 9 RTG cranes are being used right now at the terminal at SSA. Next slide. So this just gets into the insights and challenges from the technology demonstrations. Again, I mentioned that there were some operational challenges, like some of these units weren't working as intended. Some of these models weren't able to work for the needed amount of shifts. And then there were some safety concerns, specific to some of these units, which includes, some of these doors were automatic when the operators were used to manual operated doors. There were some instances where these doors just kind of like did their own thing and nearly injured one of the operators trying to exit the vehicle. So that was one of the issues that we had brought up during our demonstrations. Next slide. Again, we also had some charging infrastructure issues, as I mentioned before in one of our previous demonstrations. Sometimes, there were vehicles that couldn't sustain a charge. There were issues with, the charging systems itself not working. And what's really important in these cases is that we have, about a good percentage of uptime. And some of the cases that we've encountered here, we didn't have that high uptime that's needed for these busy terminals. And also another is to engage with the utilities often. And I think Scott had mentioned about, like the utility providers and, needing the required amount of power to the terminals. And so if this is the case for you, always engage with your utility companies early and often and get to know them. Next slide. So another issue is just the field certification and permitting involved with installing these chargers as well. Just something to note that it's not just always plug and play, specifically for port operations. And in order for these operators to actually use these new technologies, there has to be a high level of confidence and reliability. So that's one of the important things that we look out for when we're testing out these types of equipment. Next slide. And then the vendor and OEM participation, customer support is highly, highly important. During those times when we had equipment down or charging systems down, sometimes it would take them 1 to 2 days to get back to us. And I know that these are just for pre-commercial units, but and fortunately for the commercialized units that are out there, I'm sure the uptime is higher and there's great customer service. It's just something that we've noted when we did our demonstrations was just the amount of time that it took to get someone to come out to help us. So that was some of the challenges that we had experienced. Deployment challenges like increased cost prices of ZE, CHE continue to rise relative to diesel operations. Sometimes it's not feasible for terminals. They would need some grant assistance in order for them to be able to use these pieces of equipment. And so a lot of what we do is look out for grants to help support our terminal operators. Next slide. All right. I know I went through a lot. If there was some questions after today's session, please feel free to reach out to me at this email here. We also have websites available for more information about some of our programs as well as some of our project initiatives. And Heather, I'll turn this back over to you.
Thank you so much. So we're going to move on to the Q&A portion of the webinar. And so I see that there have been some questions that have already been submitted. One question that I think is a good general one to go and start off with. So this was asked early on, and I think that some of our speakers did touch on it somewhat, but I think that there's more to add on this topic. Do you have case studies on real-world usage of electric equipment? So examples of good use cases or typical runtime for different types of operations. And I was hoping that perhaps I think maybe Preston and James could talk a little bit about some of the equipment that is available through your respective companies and some of the current real world uses that you see people using and some of the run times and charging times that people are using.
Go for it, James.
Okay. Yeah, sure. So I touched on a use case during my presentation, but in general for material handling, especially the counterbalance forklifts, there's now units that run from 3,000 pounds all the way up to 36 tons. So there's electric equipment out there. Now, of course, the runtime will vary very drastically between the two, but kind of your generic 2,000 to like 5,000 2 to 5 tons equipment. We see runtime between about 3 to 11 hours. And again, that always varies on your usage and the size of battery. So the one thing that's unique for material handling is we have a lot of flexibility in the size of the battery that we have. It's not something that's like embedded in the trucks typically. And even if it is, there's usually different options. So we have a lot of flexibility to kind of size the batteries and the charger size to your actual runtime you need. As we get to the bigger trucks, that does become harder and harder. So usually if you run into a runtime issue, it'll be on the bigger units that are like 7 tons and bigger. That's when you'll run into runtime issues typically because you just at some point you run out of space to put more battery in there. But in terms of case studies, we've we've got basically every application out there that moves product, we've electrified at least once or so. So we've got applications that run, 200 hours per year, like a retail store that we've electrified, and we've got equipment that runs outside 24/7, in Michigan in the winter that we've electrified. So it's just each application has different challenges that we usually have to walk through, but we can basically do anything. It just becomes a matter of um, the time and effort it is to go through the process.
The material handling market and the mining industry is much more advanced than the off-road industry is, and so there's much better information from those two industries that I'd point you to. But from a construction and agriculture off-road perspective, what we're seeing in the market, generally speaking, is a lot of applications are hitting the 4 to 6 hours of runtime. From a Deere perspective, we're targeting more of an 8 hour runtime and doing everything we can to get the energy on board to accomplish that. To James, I'll echo James' comments. It is customer, application, job site specific. You get nuances that really make a big difference in swing from having more than enough energy to having not enough energy on the vehicle. So it varies quite a bit.
And as a follow-up question to Scott, so as we've discussed through these presentations, different equipment have different battery sizes, and that can take different amounts of like charge time and run times. What are I know that your equipment, as you talked about, can have level 2 charging. It can have DC fast charging, different power levels. What are some of the different power levels you've seen people choose for different types of equipment with your products?
Right. Yeah. So, power levels are an interesting thing because it may be the same vehicle, but how they use that vehicle may change their power level. So in the case we talked about, LA Unified School District, 200 electric school buses. So every night they charge 200 of them at level 2. All right. So 19.2 kilowatts very easily because they have a long dwell time. But they also have cases where they need midday opportunity charging. So a route's too long for the bus. So they come back and they need faster charging. So they'll do it with 60 kilowatts of power to get charged much faster. And they're looking at also putting a couple 180 kilowatt chargers in for very fast charging. So same vehicle, but just different usage.
And we received a question that had to do with battery life. So depending on the equipment, there's a lot of pieces of equipment or vehicles that have battery life that's warranted from 7 to 10 years. But a lot of these pieces of equipment are expected to last longer than that. And so the question is, for equipment that's expected to be retained past 10 years, what's the projection in the equipment for the battery life and the need for replacement? So I guess for both James and Preston, what is the warranty on some of your on the battery life for your equipment? And then how long is your equipment expected to last? And what's your expectations for customers in terms of what when you're prepping them for this?
Yeah, I guess I'll have this one. So the warranty, it can vary a lot. As I mentioned, there's the different battery technologies that are out there, which will vary the warranty. Kind of the standard typical warranty is around 7 years, and then we talk in truck hours of usage, about 12,000 hours of truck usage. That's the warranty. And usually, kind of the expectation at the end of warranty, most of the terms say the battery will have about 70 to 80% state of health, which means, let's say you started with a 100 kilowatt hour battery, at the end of warranty, it'll be between 70 and 80 kilowatt hours fully charged. So there's still plenty of life and runtime of that battery beyond the warranty period. The higher end batteries, as I said, the batteries started to segment out the different chemistries and technologies. We are starting to see some of the higher priced lithium batteries will have, 10 years, 20,000 hour warranties on the battery. So it will, again, it kind of varies on your product. we typically expect in material handling, we have a lot of applications that run it very hard, 24/7 for like 3 to 5 years. And then they will turn around and it will go into a secondary market for considerably longer time than that. So again, as your battery ages, it'll just find different use cases as it goes along.
From a Deere perspective, our BEV vehicles are not in the market yet, so we haven't released our warranty structures inside of that. But I think James summarized the state of the industry pretty well there.
Okay. And so the next question is specific, I think. I believe this came in, I believe it was during James's presentation. So it's a specific question. Was the increase in electricity cost identified for the warehouse in Utah that switched to electric? Was that a monthly or annual increase? I think they just wanted a little bit more details on that.
Yeah, so as we go through the process, we do ROIs, which goes through the calculation of the energy cost is definitely part of it. Of course, I don't have their post-installation utility bills in front of me, but I just kind of did some quick math as I saw that question came in. So there are 35 units. Their units kind of average about 2.6 kilowatts in use, and they're running about 3,700 hours per year. So their monthly increase in electricity is about 28 megawatt hours monthly. And their utility price, at least I had in the original ROI from like 2021, was just over 7 cents per kilowatt hour. So you're looking at about $2,000 for those 35 trucks running 24/7 per month. That was back in 2021 prices. Of course, I don't know what it's changed to since then, but that is a point as you go through these studies, the ROI calculation will be different in California based on their prices versus, the Pacific Northwest where we have cheaper energy due to hydropower. So it'll be very dependent on your location.
And then we had a question about charge management systems. So we did have more than one speaker who at least touched on this, but I wanted to just because there was someone who asked a question about it, if you could elaborate a little bit more on how your equipment, your products can use charge management systems and how they can integrate with that.
Yeah, charge management and visibility to charge management is a pretty key piece in my opinion. And if you have knowledge of data from the vehicle as well as data from the charging system and even data from the site, you can get really creative and specific on how your charge strategies flow. And so I think examples of that range from more advanced fast charging algorithms that you can apply to vehicles and get faster charges out of existing hardware. It also comes back to site power management. If you're running air conditioners or heaters or other power intensive things on the site, and your site has to manage that power trade-off between charge sessions and HVAC or other necessary infrastructure. Some of those charge managements start to play in that area where you can pretty rapidly switch power from one application to the next and make use of that. But it can be pretty simple in terms of a one-for-one charge station and vehicle. It can be very complex with multiple charge stations and site power management. But it is a pretty important piece. There's a lot of third-party softwares out there that are starting to get really good in this space. And as long as they're using the same protocols as what the hardware manufacturers are using, then eventually you should be able to make a cohesive system.
Yeah, we integrate a lot of charge management into the systems we put out. As Preston alluded to, you may go one-to-one with the charger, or may go many vehicles to fewer chargers. And in that case, we're able to get very different types of charging where the first vehicle in may start charging at 120 kilowatts. and the next one 60 kilowatts, and the next couple at 30, and that can flow across, so you get your first vehicle out very quickly. Or you can balance it. So you may have it so that if you have a dozen vehicles charging and it happens to be overnight, you may have the first 6 charging at very high power initially, and then it switches over to the others later instead of trying to get a total amount of power that equals max power for every charger. So, charge management is absolutely critical to, keeping costs down as well as getting vehicles in and out of charging rapidly.
Rose, is the Port of Long Beach engaged in charge management?
From the perspective of the demonstration, we do look to find ways where we can improve or that makes the charge management system, user-friendly for our operators. I don't have the exact details or specifications on that, but it's one of the things that we look into, as well as, how can we also, help out the grid by energy management systems as well. But these are things that we look into when we're doing these demonstrations. So yeah, it's one of the things that we look into.
Okay. Well, it is 3:30. Any final thoughts from anyone? Well, thank you so much for presenting. I really appreciate it. And this has been super informative. And I think that we'll end it now. Thank you, guys.
Thank you very much.
Thank you.